Started our Python journey several weeks ago. I had you enter a program to demonstrate the workflow of creating a Python project, testing it, debugging it, and saving it. So this was the project you created. It was a project to figure out what the prime factors were of a given number. And I'm just going to run it over here. So if we enter a number such as 24 and press the enter key, I'm told the prime numbers are 1 times 2 times 2 times 2 times 3. And then I'm told I can enter another one, and if I want to end, I can press 0 to end. Let's do a little bit bigger number. And here the prime factors of 1, 2, 3, 4, 5 are 1 times 3 times 5 times 823. And yes, 823 is a prime number. If I do a prime number like 17, then I'm told it's a prime number, and 17 is simply equal to 1 times 17. And if I press a 0, the program ends and we're told goodbye. Now at the time when we created this, I told you not to worry so much about the code. I wasn't teaching the code at that point. I was teaching the process of how to develop a Python program. Now though, let's come back and look at the code, because we now have enough experience under our belts to understand what's happening here. In this particular case, we used some loops. And since we're starting to study loops, let's take a look at this program. So here's our code. We simply had some comments. We had some print statements that talked about what the program would do. Nothing new there. We started with a variable called num equals 100, and then I have a loop here while num is greater than 0. So num has a value of 100, and 100 certainly is greater than 0, but then we're immediately asking them to enter num. And if they do put in 0, then the program's going to end, because our next line is an if num does not equal 0. And if it does equal 0, we get this else of print goodbye in the program. So we've looked at if conditionals. That's not new to us, but the while loop here is. And so that's a nested conditional inside our while loop. And we'll talk more about that next week. Now, if it's not equal to 0, it's going to run our if fork. And here we have prime factors equals a string of value of num, whatever num is, plus, and we're going to say it concatenates equals 1. So that's going to be the beginning of our string output. So wherever the number equals 1. And then we're going to set a Boolean value of prime to true. We're going to keep track whether this is a prime number or not. And we'll know it's not a prime number if it's divisible by something other than 1 in itself. We have a new num. We're going to work with a copy of num. So we maintain the value of num that we can use in our output if we need it. And now we're going to go through a loop. And we're going to start the loop starting with 2. So here we're using a for loop. We're going to go from 2 to the value of new num. Actually 1 less than new num. Inside that for loop then, we're going to do another loop. Now we're using a while loop. So now we have a nested loop inside a loop. So we have a while loop nested inside of a for loop, just like we nested if structures inside of other if structures. We can nest loops inside of loops. In this case, we have a while loop nested inside of a for loop, nested inside of an if conditional, nested inside of another while loop. And here's our while loop. While new num mod I, whatever the value of I is, equals 0, means it's evenly divisible into our new num, then we're going to say prime is false, because now it's divisible by something other than 1 and itself. New num equals new num divided by I. So we're going to bring new num down by taking that I factor out. That number we just discovered was part of the prime factors. We're going to take that out and divide new num by I. So new num up here is going to be declining, which means our loop is going to be shortening along the way. And we want to add that value of I converted to a string and an X for the multiplication sign to prime factors. So we're going to build this string here. So if 2 is evenly divisible by 24, now we're going to get 24 times 1 times 2. And then we have an if statement. So after we've gone through this loop and we've exhausted all the values that could possibly be divided into our number, if prime is still true, so I could say if prime equals true. I don't need to do that because this does evaluate as a true or false value. So if it's still true, then we're going to say prime factors equals just the x and the number itself. It's only divisible by 1 in itself, and we're going to print out that that number is a prime number. We're not going to do a new line character at the end, and then we're going to print the prime factors, which could be the string if it's prime of being 1 in itself, or otherwise it'll be the string that we built. And that is how we find the prime factors of any integer. And then again, if they choose 0 as the number, then we're going to end the program. And that is how we would use loops, in this case nested loops, we'll talk a little bit more about next week, but here are the nested loops coming into play in creating a fairly complicated program, but not a whole lot of code. By having things repeat over and over and changing those values along the way, so eventually it exits those loops.